Hello, grade 9. Here we are with lesson number 7, complex chemical reactions. So we're doing 3 more reaction types today, and they're a little more complicated than the ones we did last class. So here's your template for today. You might need more space in this depending how big you write, so you can always kind of adjust the template as you go. So complex chemical reactions, of course, is our title. And we're going to have a symbol of the reaction type for double displacement here. You'll have a pH scale here. You're going to do a data table for a virtual pH lab and the combustion reaction type. Depending how big your notebook is, you may also have space to do some practice and identifying. We're going to do some 6 or 7 more equations to practice balancing, identifying of the new types, and then a big worksheet for homework that will include all the types for you to practice reinforcing that skill. Because like I said before, when it comes to balancing and identifying, it's all about practice, 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 practice. Okay, so first type of reaction is a double displacement reaction. I want you guys to draw this one with color. Okay, so show the A's, switching up the D's, use the right colors to help make sure it's really clear in your diagram. Okay, so a double displacement reaction is where you have the ions of the 2 different compounds are going to switch places. So the ion here, the D ion, is going to switch from being with the A to being with the B. And the C ion is from being with the B to being with the A. So these ones often are going to result in a precipitate as a product. So the example we looked at last class with the virtual lab, the sodium sulfate and barium chloride reaction, that's an example of a double displacement reaction. Sometimes people call this a double replacement reaction. Both terms are correct. Okay, but you have 2 compounds which contain 2 parts, and they're going to switch both of them. It's like the single displacement, but instead of having only one thing moving, we have 2 things switching around. So for this reason, because it's ions switching, we tend to see it with only ionic compounds. So how do we identify an ionic compound? Who can remember how to do that? Well, ionic compounds, of course, are those between metals and non-metals, where we have an ion made with a positive metal and a negative non-metal, because they're giving and taking electrons. So neutralization reactions, we're going to talk about those next. Here's an example here. Those are a type of double displacement reactions where you have an acid and a base that are going to form an ionic compound, which would be the salt and then water. So the acid is an ion plus hydrogen, the base is an ion plus hydroxide, and it makes water plus a salt. So this is very similar to this one. So let's talk about acids and bases and the pH scale. This is the drawing I want you guys to draw. It's a pH scale going from 0 all the way to 14. And make a note the hydrogen ion and hydroxide ion kind of concentrations are what does this here. If you don't have to draw this one, don't worry about it. Okay, so the pH scale is what we use to measure the concentration of hydronium ions. H plus ions are called hydronium ions. And notice how pH is small p and big H, because the original term for this is pouvoir hydrogène, and that's the power of hydrogen. It was first described in French. So we have a little p for power, big H for hydrogen. So in a neutral solution, there's going to be equal amount of these hydronium ions and hydroxide. Remember hydroxide from our polyatomic ions lesson is OH minus. So at exactly neutral pH of 7, it's going to be OH minus is equal to H plus. Now this scale is logarithmic, which means as you go from 0 all the way to 14, and 7 of course is our neutral point, each value indicates a power to which 10 must be raised to equal the number. So let's break that down. What does that mean? That means for the concentration or power of hydrogen for a neutral pH of 7, really that's 10 to the power of 7. Okay, it's a negative logarithmic scale. So 10 to the power of 7 right here, 0.0001. Okay, and then 10 to the 0 just makes a 1. 10 to the negative 1 is 0.1. So you can see all the decimal versions of this here. And so when it's changing from one point to another, it's not actually just small value, like 1 point only change. It's actually changing by a 10th power. Okay, so be careful with that. When you do logarithms eventually in math, you'll kind of have a heads up. That's what this is about. So it's it's a great way to do it because that way we don't have to worry about doing scientific notation or doing really big or really small numbers. Everyone who's a chemist just knows that pH of 14 really means 10 to the power of negative 14 hydrogens. Very, very little hydronium ions, mostly hydroxide ions because they're alkaline. So the alkaline end has more hydroxide, the acid end has more hydrogen, and at neutral pH, these two are exactly equal. Okay, so a neutralization reaction is a double displacement reaction, but we're going to have an acid and a base. And it's going to then form a salt and a water with a neutral pH. So the initial reactants are acidic and basic, with an acid and a base. One on this end of the scale, one on this end of the scale. And then when they react, the reactants are going to be neutral, so right here in the middle. So what happens is the H plus ion from the acid is going to combine with the OH minus ion from the base. Okay, so if we actually go, here's the example here where we have HCl and NaOH, the hydrogen and the OH, hydrochloric acid and, oh my gosh, sodium hydroxide. Wow, that was a blanking moment, guys. Sorry. Hydrochloric acid and sodium hydroxide are going to react. The hydrogen and the hydroxide here are going to combine to make water, and the sodium chloride makes the salt. Sodium chloride. Okay, so let's go back here. So you're going to do a little virtual lab now, and you're going to predict and kind of get an idea of how well you understand the pH scale. So you're going to predict a pH for all these compounds. So for seawater, stomach acid, battery acid, tomatoes, soft drinks, and pure water, what do you think the pH is in a scale of 1 to 14 or 0 to 14? And then you're going to use pH paper, virtual pH paper, to measure the pH of the substance. So if we were in the lab, we'd use pH paper and pH probes both to measure the pH of different things in this unit. But unfortunately, of course, we're not in the lab, so we're going to do a virtual lab. This is not a big virtual lab. We'll do a much bigger one on acids and bases next lesson. But for now, just kind of familiarize yourself with the scale. So you're going to use the link to predict the pH and then check the pH of the pH paper and see if you're right. You can use the check button to make sure you're right before you record your final answers. There's no analysis questions, just make this table, write your predicted, and write the actual correct answer below. I'm curious to see how close you guys are. Some of these ones, you should probably get something pretty close, and you might be quite off. I know I was incorrect by 2 pH values for one of these ones that I tried out myself. So here's that lab will look like, and what you'll do is here's the different substances. You'll predict your pH here with a little up and down, and you'll rip off a piece of pH paper and dip it into each test tube. It'll change color, and you compare it to the pH paper scale to see the pH. And then you can always click check and see if the pH you put here in your predictions is correct or not. And you can change it by reading those on the pH paper. Make sure you rip the pH paper off. If you don't hold it high enough like this and then down the next test tube, it keeps going the first one. I know I mentioned the first one like 5 times by accident the first time I did this lab. So rip the pH paper off, lift it up high, and then drop it into the next test tube. Okay? All right, so just a quick little virtual labs to practice pH paper. Okay, our last kind of reaction we're going to do in this unit is combustion reactions. And this is the drawing you have to draw here. Combustion reactions, just this little one. So combustions are really common in everyday life all the time. And they're often used to provide both heat and light. And these type of reactions are going to give us a large amount of energy because of the nature of the reactants in the reaction. So most of the vehicles we have today, not all of them, of course, we do have some electric vehicles that exist, but most of them rely on fuel in the form of a hydrocarbon. And a hydrocarbon is just a compound made of hydrogen and carbon. Okay, so here's some examples of hydrocarbons. There's just straight carbon with hydrogen, lots of both of them, and the bigger the compound is, the more bonds there are, the more energy it has. Okay, so the larger the molecule is, the larger the hydrocarbon molecules are, the bigger, the more energy they contain. Why do you think that is? Well, we already talked a little bit about the fact that the energy in chemicals is in their bonds. So the more bonds there are, the more energy there is in that reaction. And the way you can identify a combustion reaction is because the reactants are always going to be some sort of hydrocarbon plus oxygen. And the products are always going to be carbon dioxide and water. So these three are always constant. It's just the hydrocarbon that will change. And it's always going to have some combination of carbon and hydrogen. So like this one was C2H6. This one is C3H8. So you'll see different combinations depending on the hydrocarbon being burned in that reaction. Okay, so let's practice. So here's 7 reactions of the 3 types we just learned about today. I want you to take a minute, balance them, and identify them. So pause the video and give it a shot. Okay, so let's check your work. After you've made sure you've done this yourself first, just go right to the answers, okay? It's important you practice. So the first one we have is a neutralization reaction because I'm producing water and I have an acid and a base. The H2, sulfuric acid, and sodium hydroxide gives me water and sodium sulfate. Wow. And this one's combustion. I've got water and carbon dioxide as a product. Neutralization. This one was already balanced for us. A double displacement, a combustion, neutralization, and another double displacement. Notice the similarity between neutralization and double displacement. They're really the same thing. It's just that neutralization is a double displacement with an acid and a base. Okay. So what you're going to have to do for homework is upload the notes, and you're going to do this practice sheet. I'm going to show it to you now. It has a bunch of questions. So this is what I'm giving you because you can fill it in digitally. There's another worksheet I'll post for the homework for review for the unit test. That works easier if you print it out, but you can still do it for review practice. This also includes some background and kind of how-to for balancing different reactions. If you're still not 100% sure, this is a great place to look for some extra information to help you out. I know this is a challenging thing to do, especially hard for Mr. Byatt and I to help you guys understand this virtually, but hopefully with some practice and continued kind of grit to get through, as Mr. Fuller would say, then you'll get there. So we have some background information here, how to balance, and some examples of balancing process, the checklist, and the types of reactions. And then there's practice questions. So for each question, there's the reaction. And what you can do is you just select it, copy it, and then paste it, and then just add coefficients. Like I can add a 2 here if I need to, and a 3 here, and an 8 here. Of course, that is very wrong, but I can just do that instead of typing it out bit by bit. It'll make your life much easier when it comes to doing the practice problems. And then below, what kind of reaction is it? Okay, just copy this down and then balance it and say what type of reaction it is. And there are 18 of those problems, plus there's 4 combustion ones to do as well. Okay. So that's your homework, is to do those practice questions. We need to practice the skill again and again and again to master it, okay? You'll be much better off next year if you have this figured out really well. Okay, so that's it. You're going to upload the notes as well as that completed worksheet to the page. And if you guys finish this by the end of the day on Friday, you will have no homework for your 4-day weekend. If you don't finish by the end of the day Friday, it's okay. You have a 4-day weekend to do it. But if you want to have that weekend to not do any science homework, then get her done, guys. All right, take care and have a good day.